Assalamualaikum warahmatullahi wabarakatuh. Welcome to another computer science lecture. So we have started discussing section number 7, algorithm design and problem solving, and in the previous lecture we discussed section 7.1, system development lifecycle. So today we are going to start section 7.2, computer systems and solution design. Now keep that in mind that these aren't exactly the accurate names of these subsections. In your Cambridge syllabus, I'll show you like this. Statements are given and description are given rather than exact names, so I've just converted those instructions or those statements into subsection names or titles on my own, so you don't have to agree or disagree with them. Just remember that whatever are the contents required for a specific section, they're all present under this lecture or under the discussion of each subsection. Now the first thing over here you need to know is that what exactly is a computer system. A computer system is made up of softwares, hardwares, data, communication, and users or people, which can be divided into a set of subsystems. So in a computer system there are always 5 components involved: software, hardware, data, communication, means communication media, and users. If you take out any one of the following, then your system just simply cannot exist, or it cannot be labeled as a system. A system has the capability of being able to be divided into a set of subsystems, and each subsystem can further be divided into more subsystems until each subsystem only performs a single task. Means you can decompose it. In order to depict this concept, and we have a term that is known as top-down design, and it means you break the problem into smaller sub-problems and then solve them one after the other in order to get the bigger problem solved. This is also known as stepwise refinement. Now in terms of computer science, or for the sake of paper 2 specifically, whenever we have the term problem, then that basically means that you need a task that you need to perform, and for that you need to develop some system or a software. That in terms of computer science, or it's a jargon for computer science or IT, that means something that needs a software or program to be developed. Now how do you decompose a problem? A problem that uses a computer system for its solution needs to be decomposed into its component parts, and the component parts of any computer system or any problem are always input, processes, output, and storage. Okay, so basically input comes from the user or from the environment, then the microprocessor carries out some processes on it, and then some output is displayed via an output device to the user, and these results are often stored on some form of storage media as well. Now in order to depict this decomposition of a problem or a top-down design, then there's something that is known as structure design or structure diagram, which we make, and it shows the design of a computer system in a hierarchical way, with each level giving a more detailed breakdown of the system into subsystems. Like, this is the name of your system, it has these 3 subsystems, and then each subsystem is further divided into these subsystems, and so on. For example, if you have an alarm app, then you can have 3 subsystems as set alarm, check time, and sound alarm. And then they can further be defined as the set alarm can be defined as set time, at what time do you want your alarm to sound, or turn the alarm on or off, that is known as snooze or dismiss. Sorry, this is simply just turning on and off the alarm, whether you want the alarm to sound or not. Check time cannot be defined anymore, this is a single function. And sound alarm can have play sound for 2 minutes, check off or snooze, or reset or clear alarm. And if we talk about another example, then For a school website, the main system is the home page or the school website. Then we have student area, information for visitors, and contact. Contact is a single page. There are not any further divisions, whereas information for visitors have about us and detail about faculty members, whereas student area has event calendar, results, and worksheets, and so on. You can elaborate. Now, when we talk about how to design a solution for a problem, then the first thing for, or the topmost thing for that, are writing algorithms. What is an algorithm? A diagram or written sequence that allows or shows all required steps to perform a task along with the order which must be followed. Now, there are two ways of writing algorithms. One is known as flowchart, the other one is known as pseudocode. Just remember that in simple terms, algorithm is the name of depicting or writing down your logic, like what logic or what steps are you going to take in order to solve a given problem. And for that you have two options: either you make a flowchart or either you write down a pseudocode. Flowchart is a diagram that shows all the required steps to perform a task, and if you write them down in a written form, then that becomes a pseudocode. If you draw a diagram, the depiction of algorithm by symbols is known as flowchart, and the depiction of an algorithm in simple English key terms, that is known as pseudocode. A simple method of writing algorithm using English-like key terms which is not bound by syntax of any given programming language. This is supposed to be syntax free. Then we have something that is known as library routine. A library routine is a pre-written function, means it is a piece of code that has already been written and it has been embedded into what you can say the library files that are provided when you install any specific programming language or its IDE on your system. It is pre-tested, it is pre-debugged, and it is used to perform a frequently used operation within a program. They can be called whenever needed. They can be reused by any other program. Subroutines, they are pre-written functions which only form a subprogram or a subsystem but not the whole program, means they provide some very small, very short capability inside. They are a short piece of code which provides some which enables you to perform some simple or some very short task inside your software which you are developing. So you don't have to write the code for them. You can simply call them from the library files and they'll just do the task. For example, close button is or the print option is used in almost every software nowadays, so they can be considered as subroutines. Whereas let's say the whole file menu, that can be a library routine where you get multiple functionalities or multiple options. Library routines and subroutines, they are both written inside library files and they are both pre-tested, pre-written, pre-debugged pieces of code. Just that library routines perform a larger function or a more complex function, whereas subroutines perform simpler tasks. Hope you have understood that. Anyways, so for making a flowchart, these are the symbols that you need to know. This ellipse is the start or stop symbol. We start our flowchart with this and we end our flowchart with the same symbol. Then the next one, a parallelogram, depicts input or output. If you have to output something or input something, then you use this symbol. For processor or function, we use a rectangle. A double rectangle is used in order to show our subroutine. A diamond or rhombus is used in order to show decision making, and flow lines are used in order to tell the sequence of the program, whereas this circle, hollow circle, is used as continuation in order to extend your flowchart onto the next page. Next we have before we start discussing pseudocodes, then there's something that we must discuss first. That is known as data structures. There are three data structures that are a part of your syllabus: variables, constants, and arrays. Variable is a memory space whose value keep on changing during the run of the program. It can only hold one value at a time. Constant is a memory space whose value doesn't change during the run of the program. Again, it can only hold one single value. Array is a memory space which can hold multiple values of same data type. Okay, so you need to keep these things in your mind while developing your algorithm, means either flowchart or pseudocode, because whatever data you input in a program, they're always stored in variables, and then they might be stored onto a file, but that is a discussion for later chapters, section number 8 specifically, not for this. So without making variables or using arrays or constants, you cannot write an algorithm. So pseudocode, what exactly is a pseudocode? It does what its name says. It is a written piece of instruction that is pretending to be programming code. It is a simple method of showing an algorithm. It describes what the algorithm does by laying out logic in simple English key terms. And data items to be processed are given meaningful names. Always remember this, always give meaningful names to your data items or your functions or your variables or your programs or your what you can say, your arrays and constants. And pseudocode is not bound by the strict syntax rules of any programming language, but in the new syllabus the examiner has included some specific formats, some specific syntax for performing or writing for performing different tasks or writing some specific parts of the pseudocode. So you have to follow that if you want to get full marks in your paper number 2. After writing your code, always dry run it to check for errors, means go through it one time at least in order to be sure that you have not made any logical or syntax mistakes or errors. The first thing you need are operators in pseudocode. A value is assigned to an item or variable using the arrow or the assignment operator. The syntax is variable name and then arrow and then the value. For example, price arrow 0 means that you made a variable named price in the memory and you assigned it the value of 0. Now percentage sum divided by total into 100. The program or the algorithm is going to run this formula, and whatever answer it gets, it is going to store that in the variable named percentage. Then again, gender is equals to m, message equals to hello plus name, pass equals to false, and so on. This is the function or the syntax of a assignment operator. Next we have mathematical operators: plus, minus, multiply, divide, raise to power. This is known as cap, and we use this when if you want to show some number in terms of power. For example, 2 raised to power 8 or 10 raised to 10, for example 2 raised to power 10 or so on. If you want to group segments of a formula together, then we use brackets, and if you want to apply a mod function, we use the percentage sign. Mod is the modulus function. It divides two given numbers and tell you the remainder. What values will the following variables have after the assignment have been completed? Try to solve it, and I'll simply leave the solution to this in the description below. So do let me know in the comments how many of you were able to get the right answer. Then we have comparison operators. These operators are used to compare two or more values or statements. less than, greater than, equal to, greater than or equal to, less than or equal to, and this symbol means not equal to. So there's another mathematical operator that is okay, we have discussed divide. Then we have logical operators and or not. They are used when you want to apply one or more than one conditions to some variable or statement. And means both conditions should be present, or means any of the 2 or 3 given conditions should meet, and not means that the following condition should not be met. For example, if A is 30 and B is 50, then A and B would be false. A or B would be true, like either A or B. A not B is also true, they both are not same. One is 30 and the other one is 50. Other key terms in pseudocode, the first thing, declare, to set or store value of a variable, or to initialize or declare a variable. The syntax is simple: declare variable name and then variable type, data type. Read or input is used to take data input from the user. Read is usually associated with getting data from a file, whereas input is used to get data from the user. Now this read part we are going to use in our next chapter or next section, section 8, but you should know it already by now. Print or output is used to display some message on the screen, whereas write keyword is used in order to store some data onto a file. Again, you can use write to display some information as well, but it's better if you use write specifically for writing data to file. And end is used to mark the end of an algorithm. Just keep in your mind that all key terms should always be written in all caps. Conditional statements. When different actions are performed by an algorithm according to the values of the variables, conditional statements can be used to decide which action should be taken. There are two types of conditional statements. A condition that can be true or false, such as if then else and if. This is the first type. The other one is case of, otherwise, and case and. This we use when we have to choose between several different values. Now if you have to write an if then else statement, then here's an example for that. Input height. If height is greater than 3, then print yes you can write, else print you are too small to write, and if. More than one logics can be added in a single if statement, that is known as nested if. For example, percentage integer. Declare percentage integer. This is the initialization of a variable with data type integer. Output, please enter your percentage. Input percentage. If percentage is greater than 0 or less than 100, less than 0 or greater than 100, then output invalid percentage. Else if it is greater than 49, then print pass, else output fail. Now the number of ifs that you would open, 1 and 2, is the number of ifs that you are going to close at the end of your if statement. Next we have case of, otherwise, and case. For case condition, the value of variable decides the path to be taken. Several values are usually specified, otherwise is the path taken for all other values. The end of statement is shown by AND case. For example, case variable name of 1, 2, 3, 4 and so on. Otherwise, instruction on what to do if none of these options match, and then AND case. For example, case working days of, if the user has chosen 1, then you would display Monday, 2, Tuesday, 3, Wednesday, Thursday, Friday. Otherwise, print please choose a valid day. End case. Try to solve this practice session. Okay, and let me know if you are able to solve it or not. Okay, so we'll keep it till here. The video is getting long. Oh, or we just have one sub. Okay, let's just continue. Loops. When you want to perform a single task repeatedly, then that is known as a loop. There are three different types of loop in pseudocode. There are more in actual programming languages, but over here in pseudocodes or in Cambridge syllabus we just have three. When you have to repeat the same task for a set number of times, we use the for to next loop. When the logic needs to be repeated until a condition is met, then we use a repeat until loop. And a repetition where the number of repeats is not known, that may never be completed, that is known as a while, do, and while. Loops are also known as iteration or repetition. All types of loops can perform the same task. It just depends how you lay out your logic. For loop is a precondition loop, as this test for existing the loop is at the beginning of the loop. Syntax is for, counter variable, start range to end range, and then you write your whatever you want the loop to do, and next count or next counter. For example, if you want to print a line of stars 10 times, or if you want to print 10 stars, declare counter as integer. For count 1 to 10, you have to use the assignment operator over here, output star next counter, so it will print a line of 10 stars because the counter is going from 1 to 10. Repeat until is known as a post condition loop because the condition is checked after the loop has been performed at least one time. The syntax is repeat, task to be performed until, and then the condition. For example, if you have to do the same thing, means we have to print 10 stars, declare counter integer, repeat, output star. We are showing it in inverted commas so that the value whatever is inside the inverted comma will be printed as it is on the screen, whereas if you don't put inverted commas and write down the variable name, for example you write output counter without inverted commas, then the value of the counter would be printed on screen. And then we increase the counter equals to counter plus 1 so that it can reach till 9, from 0 till 9 or from 1 till 10, because we need to get it printed 10 times until counter is greater than 9. Like it will start from 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on. It would work something like this. The program is going to read okay, output star. It would simply print a star on the screen, then counter equals to counter plus 1, so from 1 it will become 2, and then until counter is greater than 9. Okay, the counter is 2, it has not reached 9, so it will again go to the beginning, means the repeat keyword, and then it would print another star. The counter would become 2, and then again the so on 3, 4, 5, 6, 7, 8, 9 and 10. Then the condition would have been met. The counter is now greater than 10 and greater than 9, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 stars on screen. The last loop is WhileDo loop, and it is a precondition loop, as the text for exiting the loop is at the beginning of the loop. If the condition does not meet, then this loop may never be run. The syntax is the keyword while, then the condition, do, and then the task to be performed, and at the end we write and while. Again we are following with the same example, printing 10 stars, declare counter integer, while counter is less than 10, do means as long as you have not reached 10, the value of counter has not reached 10, what you need to do, you need to keep on outputting stars. And then what we do, we increment the counter. So if we don't do that, then the loop will never end. Just remember that in for loop, this keyword next, it increments the counter automatically, so we do not do it manually over here. We don't write counter equals to counter plus 1. Whereas in repeat until and while do loop, we do not have any such key terms, so we manually write this line always in while do and repeat until loops, counter equals to counter plus 1. They all can be used to perform the same task. Next, we have something that are known as comments. Comments are preceded by 2 forward slashes. The comment continues until the end of the line. For multi-line comments, each line is preceded by the 2 forward slashes. Normally, the comment is on a separate line before and at the same level of indentation as the code it refers to. Basically, before every block of code, a good programmer always leaves comments in order to show what the next block of code is going to do, or what is the task that is being performed by a block of code. As well as comments also help explain the logic of the program to another programmer. This is something that has been made a must part of the new Cambridge Computer Science syllabus and the new paper pattern. If you do not write comments in your algorithms while attempting paper 2, you can lose up to 4 marks from your answer. Like if it is a 12-mark question and you write an algorithm perfectly but you do not write comments, then you will not be rewarded marks out of 12. You will be rewarded marks out of 8. Occasionally, however, a short comment that refers to a single line may be at the end of a line to which it refers. For example, while explaining a formula. For example, this is a comment. Now, these lines are not processed by the interpreter or compiler, or what you can say your IDE. They are just in the back end or the source code, and they are not displayed to the actual user. Now these 2 lines are telling you what the following procedure will do. This procedure swaps value of x and y. Procedure swap x integer, y integer, temporary. X temporarily stores the value of x, or y becomes x, and then temporary or temp becomes y, and procedure. So what this procedure or function has done, it has swapped the value of x and y. Like if x was 10 and y was 30, at the end of the procedure, x would become 30 and y would become 10. Again, these are some practice sessions. You should really try to attempt these questions, and let me know in the comments if you need any help regarding solving these questions. I hope you have understood. Take care. I'll see you guys in the next lecture. Please do comment and do subscribe to my channel. Take care. Allah Hafiz.